everybody. Thank you so much for joining us. My name is Aaron Adair. I am one of the program coordinators with the Saskatoon Industry-Education Council. I'm very grateful that my colleague Michelle Hardy is behind the scenes tonight, making sure that everything looks good for everybody. So happy that you join us for our Engineering Career Pathways panel this evening. Engineering is such a diverse and interesting career path, and so we're really excited that there are students in our province who are interested in such a unique field. So with our Spotlight on Careers, we generally want to do three things. So we want to show students post-secondary pathways within a specific field. We want to get them to know some professionals so they can see what the career paths for those professionals have been like. And we also want to give some hands-on. Now, of course, in this virtual world, we'll definitely do two of the three. I will show you at the end a little bit more about some hands-on possibilities. Of course, we're going to focus on some post-secondary and professional stories as well today. We're very happy to be coming to you from Saskatoon, which is Treaty 6 territory in the homeland of the Métis. And wherever you may be watching, maybe you're watching this recording afterwards, again, we're very glad that you could join us. So for this evening, I'm just going to go through this little rough table of contents with you. I'll go in reverse order. We are going to have 4 presentations from engineers from Hatch in Saskatoon. These 4 engineers represent 4 different disciplines of engineering. And that's one of the things we want you to see tonight, is just to see a little bit of the variety that people can find in the engineering field. So these folks are going to share their experiences with you. In the middle, we are going to be talking with Kaitlyn Dilsner from the U of S College of Engineering. She is going to be sharing some information that I'm sure many of you are interested in about becoming an engineering student and what your life and career path might look like afterwards as well. And we are going to start off this evening with a keynote, if you will, from Melanie Stair. Now, Melanie works with Nutrien at the Quarry Potash Mine. And Melanie is going to share her career journey and a lot about what she is doing nowadays. And what we really love and what you're going to find interesting, I hope, is that Melanie's going to share a very unique path that she took to getting into her position. It's something that we always talk about at the IEC, which is that career paths are rarely linear, right? There's a lot of stops and starts and twists and turns, and it all depends on the experiences that we gain both inside and outside of the workplace and academic environments, right? So Melanie's also going to share some images and descriptions of some of the unique projects she's worked on. So I think you'll find that very interesting. A little bit, if you don't know about Nutrien, Nutrien is a fantastic company that has worked with the SIEC for many projects, and we always appreciate their support. Over 22,000 employees are a part of Nutrien, and they have operations and investments in over 14 countries. Nutrien's crop inputs and services reach every major growing region of the world. They produce and distribute over 25 million tons of potash. Wow. Nitrogen and phosphate products for agricultural, industrial, and feed customers worldwide. So we are very thankful again that Nutrien is a part of this event, and we're extremely thankful that Melanie Stair is here to present for you. So Melanie is going to go through her presentation, and afterwards she's going to be here for a live Q&A. So if you do think of any questions that you have for Melanie, please type your question into the Q&A function, and we'll be sure to ask Melanie about that afterwards. So I'm going to turn it over to Melanie's presentation.
Hello, everyone. Thank you for having me today. It's a pleasure to speak with you. Obviously, I wish that we could do this in person, but I guess we will just play the hand we're dealt in these circumstances. So my name is Melanie Stair. I am the Chief Mine Engineer at Nutrien's Quarry Potash Mine Site. We are the first mine site out Highway 7, so that's west of the city, headed out towards Rosetown and Kindersley, and ultimately Calgary. We're about 10 minutes out of the city, so a nice short commute for myself myself and my coworkers. So I was asked to speak today about my career journey, and it's admittedly a little unorthodox, but I think I have some valuable lessons learned along the way. So I grew up in Saskatoon. I'm the youngest of two daughters. My father was a locksmith. My mom was a nurse. As a child, I really enjoyed tromping around after my dad. He really liked to fix things and liked to build things. He enjoyed also taking things apart and seeing how they worked, and I developed a passion for that as well. In my younger years, as I got into school, I really developed a passion or an interest in maths and sciences. I certainly excelled in those subjects, but I also really enjoyed art. I really like to sketch and doodle and a little bit of painting. So I had a good sort of two ends, I guess, of the spectrum as far as my interests go. As I got into high school, I started to have a real interest in architecture. Along with maths and sciences, I really liked the idea of clean lines and right angles and symmetry and linear perspective. I didn't consider it as an option for a career path at that point, but it was certainly something that I was interested in. At 16 years old, in grade 11, I got my first job working in a restaurant, and without getting into the gruesome details, I made a series of rotten decisions and ended up dropping out of high school in my first term of grade 12. Not the right decision, not the path to follow, but I was I just wasn't making good decisions for myself at the time. Took a couple of years of still working in food service, and I finally decided, no, I really need a grade 12 diploma. That's something that's very important to me. So I did go back and pursue it, and I got my grade 12 when I was 22 years old. I carried on working in food service and retail until this fellow came along. This is my son, Mateo. He was born when I was 25, and he really changed the way that I looked at the world, the way I saw myself and my capabilities, and he certainly made me want to do something different and something better for myself and certainly for him. So I started thinking about architecture again, and in fact, I started thinking about civil engineering, structural engineering specifically, and decided that maybe it was time for me to look at applying to engineering. I had to pick up a bunch more grade 12 classes to get the prereqs for getting into engineering, but eventually I applied to the school at the U of S, and I started when I was working on my degree when I was 28 years old. I went through the first couple of years of civil and did enjoy my classes, but in my second year, I took a general engineering class that gave me a couple of design projects in mining. And so it gave me a little taste, and I was fascinated by it. The idea of the geological engineering discipline to me was a great juxtaposition between sort of natural sciences and problem solving and innovation and technology. So I switched. I had some really good undergrad practical experience. I worked doing research under one of my professors. I got to visit a couple of hard rock mines in northern Saskatchewan through that research. One was Cameco's McArthur River mine. So that's the top photo there. And the other was Bingo's gold deposit. So that was an excellent experience. Another one of my pre-grad experiences was actually with Potash Corp, which prior to our merger with Agrium was the name of the company that is now Nutrien. I had some really valuable time in the field, working for Potash Corp at the time, and lots of underground experience. Thankfully, when I graduated, they hired me full time, and that's where I am today. So here's a shot of my graduation. I credit my son. He spent a lot of time at the university with me in the computer labs, and my professors were kind enough to allow him to sit in on some of my classes and just play Lego or whatever at the back of the room. So that was really something, and a heck of an accomplishment for both of us as a family when I graduated. So I stayed on as a mine engineer for several years at Corey. Before early last year, I was actually promoted to the chief mine engineer. So this is a good slide that represents everything that my team does. So that first bullet there talks about the different disciplines that make up our team. So geological engineering, most of our engineers actually came from the geological program at the U of S. It's got a really great mining component. We also have mining engineering, mineral resource engineering. We don't have anybody right now that is from that program, but there's it hits all the points and all of the subject matters that we deal with. We also have mine engineering technologists, civil engineering technologists. We've got some geomatics and in our surveyors, and then we also have a geologist on site. My group is responsible for ground control and rock mechanics. And actually the photo in the background on this slide is one of my students from last year. She's working to install a ground movement monitor in this photo, so that we can understand a little bit better how the ground is moving for ground control and ultimately for safety. We also are subject matter experts in ventilation and air quality in the mine. So we've got a vent engineer and a vent technician that are dedicated to our ventilation underground. We also have surveyors, so they're laying out the survey for our underground borers to cut the what I'll call tunnels. And then they're also drawing engineered excavation drawings. We've got geology. We cover both geology and hydrogeology. So geology is more the rock, and hydrogeology is any water flow through the rock. So we do have some small inflows that are a bit of a nuisance to us, and so he deals with those. Long-range planning, that's looking ahead and forecasting further out in 5 and 20-year plans. And then we also get to do some project management, which is just a dog's breakfast of different things. So when I was involved with project management, this is one of the jobs that I got to do. This is a rehabilitation job. So that piece of equipment beside me is actually just the stick or the head of a Doosan excavator. It's got on it a cutting head that we call a pineapple cutter. So it's a rotating head, and potash is soft rock, so we're able to cut through it. We don't have to blast it. It looks like I'm looking at the equipment in this photo, but I'm actually inspecting the cut. We also are involved in project management when it comes to new construction. So the photos here are from our 4-silo excavation. So this is for underground raw ore storage. And this happened relatively early in my career, and I was pretty mind blown at the time. The photo on the left shows that same size piece of equipment down in a hole. The diameter of that hole is actually about 40 feet rather, which is about 12 meters across. So it's quite significant in size. The photo on the right is once the excavation was complete. That's someone at the bottom looking up, and I'm actually, in fact, in that little red basket that appears to be hanging on a cable no bigger than a string. Also, new construction, we did some concrete work at the bottom of one of our shafts. So this was my first exposure to infield concrete work. In the photo on the left, they're tying some rebar, and in the photo on the right, close to the same angle, they've already poured the concrete. And this is a water management system at the bottom of one of our shafts that allows us to collect the water and pump it and just control where it's going. So that's all I have to share with you about my career journey. I just have a couple of things that I wanted to make sure that I hit on for you. One is, and it's evident in my case, you don't have to get it all right the first time. You know, there's an expectation that you come out of high school, you know exactly what you want to do, you go straight into the right program, you do all the right things, and you end up with a fabulous career on the other end. It doesn't always work that way. And in fact, quite often it doesn't. And I think the lesson I've learned anyway is even if you don't get it all right, the most rotten experiences will probably teach you the best life lessons and bring you to somewhere great eventually. The second note on here I wanted to mention was to be very patient with yourself. Be kind to yourself. You're not going to have it all figured out right now, and you need to be understanding and really learn as much as you can about yourself and do what you need to do to learn about you and what you want to do. Like I said, you don't have to figure it all out, so be patient. So that's all I had in my slide presentation. I do look forward to answering any questions you might have. And again, I thank you so much for giving me the time to speak with you today. Hello, everyone.
Awesome. Thanks so much for the presentation, Melanie. We're going to invite Melanie into the conversation here. There she is. Hey, Melanie.
Hi.
How are you doing tonight?
I'm very well. How are you?
Perfect. We're taking you behind the curtain, everybody. We pre-recorded the presentation to make sure we didn't have any technical malfunctions. So we hope you enjoyed that, students. We hope you learned something from Melanie there. Melanie, I mentioned in the intro that you followed a different career path, and we always love hearing those stories at the IEC. I imagine that it was pretty challenging coming back into the education system after being away for a little bit when you were younger.
Yeah, it was a bit of a shocker to the system. So I should have graduated in '95 from high school, and if you recall, that we didn't have the internet when I was in high school, so the internet wasn't of regular use to me, certainly not in an academic setting. So that was one thing. I also simple things that we take for granted now, like using Microsoft Excel or Microsoft Word. I didn't have that experience and that knowledge going in. So in addition to my studies and trying to learn concepts, I was trying to learn the software and navigate the internet to support what I was taking.
This may be a dumb question. I don't know if there are dumb questions, okay? But did you see yourself ending up where you are today back then when you went back in?
No, no, I don't, and I don't think I said in the presentation, like, my interest was in architecture, and so I was going to go kind of feel that out. You know, I didn't have great plans, and I'm not sure anything in my life has ever been set in stone in my mind. But I knew I was good at math and science. I talked about that, and I also had good love of problem solving, and the more complex the better. And so I knew I knew a little bit about engineering at the time. I really thought actually that it would be probably more about designing things or creating things, and in fact, in most cases, it's not. It's about solving problems and creating solutions more so than things.
Right on. Along those lines, what is it that you really love about your job right now?
Oh, it's moment to moment. It's awesome.
Okay.
So we're a 24/7 operation, and we are operating in a commodities market. My site in particular we have several different products. So we're a swing producer, and we sort of figuratively get the phone call to do what they need, and we have to really change our strategy on the fly. So things are some weeks things are coming at you like you're drinking from a fire hose, and there isn't much time to do the list of things that you had decided on, at the end of the week last week. So but my days pass quickly. I love my team. We've got a really great group out there, so just an enjoyable place to be.
That's awesome. And I should just mention too that, again, if anyone who's participating tonight does have any questions, please type them into the Q&A for Melanie, and we'll get to those for sure. Melanie, along the lines of just what you were talking about there, what do you think really makes a good engineer? Now, I know that engineering is a really diverse industry, as we talked about before, but whether it's people you're working with or other engineers you're aware of, what kind of qualities do you think are typical for engineers?
Yeah, I'm going to say curiosity, which I think you kind of have to be to even go into engineering. Yeah, you have to be interested in the way things work and the way the world works. And I think probably the second quality that I would hope to see in engineers is a little humility. We don't know everything coming in, and in my field especially, there is such a breadth of people with different backgrounds, different education levels, different. Some have grown up on farms. Some know like a ton about heavy machinery. I sure didn't when I started. You have to be willing and do your best to learn from everyone who's around you. There's so much information out there, and if you're curious, you can soak it all in. But you have to stay humble, right? Us engineers know about this much about how the world works.
Excellent. A few of the presenters from Hatch who we're going to see later mentioned that they didn't really know that much about engineering when they were in high school, so they were glad that even an event like this was happening, and didn't really know about that that piece. Would you agree? I also think that engineers have a really unique creative type of work as well. Creativity in a different way than some people may think of, perhaps, right? But there seems to be a lot of creativity in the work, right?
Yeah, you have to. A lot of creativity, a lot of I'd say you sort of develop a knack for it over time, but even just removing information that's not relevant to a solution, and then creating a solution from what's left. And I think the best part of it is it's all collaboration. There's no real right answer. We're all working together, and we're throwing our best ideas out, and it's a best fit solution. It's not right or wrong. So very creative, but you have to be willing to take the creative ideas from others to try to put something together.
Right, and finding solutions to problems, as you mentioned before, for sure.
That's right. Yeah.
Yeah. Awesome. I'm just going to ask you one more thing, Melanie. You mentioned toward the end of your presentation, gave some great advice to the students, and you talked about being patient and not necessarily having everything figured out. For someone who's curious about engineering, or maybe even going into first year engineering, what kind of advice would you give to a person like that in terms of that patience that you talked about, just maybe finding their way?
Yeah. So if you if you do decide to go into first year engineering, I did have a bit of a look at the re-engineered program, and I think Kaitlyn's going to speak to that later.
Yes.
But there's some good general engineering material in that first year, and that really helps you kind of feel out some different things. So if you think engineering might be the way that you want to go, but you're not sure what discipline you're going to jump into, there is some time for you to kind of figure it out in that first year.
Nice.
Get a little taste of different things.
Lot to discover. That's awesome to hear.
Mm-hmm.
Melanie, thanks again so much for giving
Thank
your
you.
time and speaking with these students. I know that students from across Saskatchewan, their parents, their teachers are going to benefit from you hearing from hearing your story and from you sharing your experience. So thanks again for being a part of this tonight.
My pleasure. Thanks so much for having me.
Awesome. You're very welcome. So folks, we're very grateful that Melanie could share her experience. As I said, we are going to move on to the second portion, which is our post-secondary portion. I'm going to tell you that we're going to talk a little bit more about post-secondary at the end. We are just going to be focusing, since there are a lot of options in the province, we just want to focus on the U of S College of Engineering program in particular tonight. And of course, there are other programs that folks can definitely look at, but we want to highlight the U of S and all the unique things that they're doing up here in Saskatoon. So from what I understand, there are a lot of paths, as Melanie was just kind of hinting at, especially after first year. And Kaitlyn can correct me if I'm wrong after this, but I believe that people may be interested in biological, biomedical, chemical, civil, computer, electrical, engineering, physics, environmental, geological, and mechanical, just to name a few. I'll ask Kaitlyn if there's more, but lots of different avenues for people to go down for sure. We want to share this video from the U of S with you. It's a few minutes. It gives an overview of their unique approach to the first year program. It's called Re-Engineered, as Melanie talked about. And we want to share this with you, and then Kaitlyn is going to be here to answer some questions after. So please type your questions in to the Q&A if you have any questions for Kaitlyn.
When we redesigned our first year program, we asked ourselves one question: what would we do if we could do anything? And what we came up with was Re-Engineered, the college's brand new first year program that's the first of its type in Canada. My name is Kaitlyn Dilsner, and I'm the college's recruitment officer. We've reimagined what first year is going to look like. We've redesigned this program for your success. We made it balanced so that everything doesn't happen at the same time. We made it hands-on because you learn better when you get to experience it. And we made it thorough, so you actually get to experience the different things you need to know when you become an engineer. We're using modular courses. What these are very short, focused, intensive courses that vary in length and intensity. This is what a traditional timetable looks like. You have your 5 or 6 classes, your midterms in October, and all your finals at the same time in December. But this is what a re-engineered schedule will look like. We've introduced just-in-time learning. So this means that the things you're learning in one class, you're going to immediately use them in another. So all of the theories and concepts from your courses weave together. We have a dedicated first-year teaching team to make sure that you have a balanced exam schedule and coordinated assignments so that everything doesn't happen on the same day. We've redesigned the schedule to make it more balanced for you. Everyone starts at the same time at 8:30. You have a common lunch break at 11:30, and the day ends in a tutorial so you can get help with your homework or study with your friends. We've created a brand new curriculum for first-year engineering. We've redesigned the curriculum to be more relevant. We're focusing on your knowledge, your skills, and we're giving you a lot more experiences. We understand that sometimes the transition from high school into engineering can be kind of tough, so we've put in lots of supports, like all of these. Instead of having to choose an elective, you're going to take a natural science series that incorporates bio, chem, geo, and physics into one course that's going to have a lot of hands-on activities. In your first year, you're going to get a lot more experience with your majors. In the fall, you're going to have a one-day discipline immersion so you can get to experience each of the majors before you choose. And then in the winter time, you're going to do a design project in the major you choose. And these are the different majors that you can choose from at USask. We've redesigned this program to make you more employable after your first year. You're going to be proficient in one programming language, you're going to have CPR and WMIS, and you're going to have CAD and project management skills. We've changed the way we grade you to help you succeed. And the best of all, no finals! We've introduced this thing called competency-based assessment. So what that means is that you're going to be tested on 3 different types of knowledge. There's basic knowledge, and you're going to have unlimited opportunities to improve. The type B is the basic skills, and with those you're going to have 2 tries to meet the goals. The final one is the type C, which is advanced skills, and that's just normal grading. You get what you get. And I've heard people tell me, well, that's just easy. Engineering is easy now. Well, not really, it's just different. Because on the type A and the type B knowledge, you have to be performing at 70%. Instead of grading you on memorization, we care about the mastery of key material. We're looking at specific skills and how well you execute those skills. We're going to give you chances to try again during our fall and winter top-ups. These give you additional opportunities to try and improve your grades, and we only use the best and most recent evidence to determine your grades. You're not going to be penalized for earlier mistakes. We've rebalanced for student diversity because we understand that you're not all the same. To help make sure that you have a smooth transition into university, we're offering a series of courses called Summer Top-Ups in these topics. It'll be a series of short tests so that you can make sure that you're up to speed before starting. The different supports that we've put in place to help you become an engineer are the daily tutorials, the first year support staff, and the fall and winter top-ups. We're doing this because more than one type of person can become an engineer. So that's the important things to know about the College of Engineering's brand new program at the University of Saskatchewan. If you're interested in becoming a future engineer, make sure to apply. And follow us on social media or email me if you have any questions.
Awesome. I know I learned a lot watching that video. I could see that it's a far different program and a really creative look at approaching first year in engineering. So that's really exciting to see. And we welcome Kaitlyn to our event now. Thanks for being with us tonight, Kaitlyn.
Hello, I'm happy to be here.
Good. Did I get all those majors, all those disciplines down that you offer at the U of S?
I think, so there's mechanical, engineering, physics, chemical, geological, civil, environmental engineering, electrical, and computer, and then biological and biomedical grad programs.
Okay. See, I was really just testing you, so you just passed, so that's good. Right on. That's really good. So a couple of questions for you, and again, if there are folks who have questions, please type them into the Q&A, and we'll pass them on to Kaitlyn here. I think some of the more basic things perhaps that people might be wondering, what are the admission requirements for USask engineering?
Yes, make sure in your grade 12 that you're taking physics, pre-calculus, and then as well as chemistry. And in those classes, try to achieve a 70 because that's what we're looking for. So make sure you get a 70 in those grades. And then we're also looking for an admission average of a 75. And that's just in your 5-subject average. So we take 3 of your, there's a formula, but it's basically your 3 best electives and then assign a math.
Perfect. And I imagine
so a new thing.
Sorry, go ahead.
A new thing is you don't have to take calculus. So a lot of other engineering schools around Canada, you have to take calculus, but if you have calculus, you're not behind at all because we're not expecting you to have that.
All right, that is a big change for sure. Some people will be very interested to know about that. And I imagine that some of that information could be found on the engineering website. Is that engineering.usask.ca?
Yeah. And you can also find the same information on the admissions page too.
Perfect. What kind of scholarships are available for students coming into engineering?
Yeah, there is a lot of different scholarships. So we give you some scholarships just based off of your grades. You don't even have to apply for them. So those start, if you have an 85 average, you can start getting those. And they start at $500. It's all the way up to have a 95 average, you will automatically get $3,000. So go check those out on the admission site and see where your average falls to see what kind of money you'll be able to get. And it's really great to keep those averages in mind. If you're sitting at a 92 spot, try to bump it up to a 93 so you can get into the next racket of scholarships. And then there's also the best and brightest, which are so by December 1st. And some of those scholarships are worth $40,000. So if you're a high achieving student, don't miss those. It's a lot of money. And then there's also another wave of scholarships that are competitive, and those are based off of financial need and leadership. And sometimes just a random criteria like a family in mining or an agriculture background. So make sure to check those out because some of them don't even get taken.
For sure. Yeah, that's advice that we often give to students too. There's just so much out there that doesn't get claimed from year to year, right? So doing as much research as possible. You never know what kind of scholarship you might be getting. I'm not sure if there was a little audio issue, but you were talking about the best and brightest scholarships, or the ones that were up to around 40,000. Was that right?
Yeah.
Yeah.
So
Okay.
those ones, the deadline is December 15th to apply, and you have to apply for admissions by December 1st. So
Okay.
if you're a high achieving student, make sure to apply because some of my friends have even gotten them and they had their entire degree paid for.
Amazing. Wow, that's awesome. Kaitlyn, we got a question that came in from down in Regina for you. Are you seeing more female students who are entering the college now, or from what you've heard of from past?
Definitely, yeah. It's definitely been something that the college has been working towards for, since the beginning of engineering, trying to get more women in engineering. In the last few years, we really increased that. We have a female dean, which we're really proud to have. But yeah, it has grown a lot in the past recent years.
Awesome. Do you have any insight too, Kaitlyn, just from your perspective at the college there, of fields of engineering that are in demand right now, or is there a pretty broad demand across the board?
I'll answer that in two ways. First, maybe directly. The areas that I've seen demand in is actually in mining and geological engineering. Has been a lot of increase, and those also have the highest wages among engineering professionals. Also, technology has been on the rise. Mechanical has always been very steady. If you want to learn more about different trends and what's been happening, if you look at APEGS, their website, they can tell you a little bit more about the different trends. And then the second way I want to answer that is the cool thing about an engineering degree is you're not limited to one profession. It's not like some degrees where you get a degree and this is the very narrow kind of work you can do. If you get an engineering degree, maybe you want to be an entrepreneur, or maybe you want to go work in a completely different field. But because you have your qualifications as an engineer, people are going to take you a lot more seriously. And you're just going to have some skill that a lot of other graduates don't have. So it really sets you apart. So that's kind of the two ways I'll answer that question.
Good. Thanks very much. Yeah, and those unique skills are very in demand now. We've heard from a lot of technology companies that USask grads are coming to them with some really unique skill sets and getting involved in the very exciting technology fields right now too. So that's definitely exciting to see. Could you tell me a little bit about like what a student might experience as a student in the College of Engineering, perhaps some groups or unique experiences that they might have?
Yeah, I think one of the biggest things about the student kind of experience and culture on campus is it's very collaborative. I think engineering has a reputation of, you like to work alone, and but that's not accurate at all. To succeed in engineering, you have to be really collaborative, and it's really tight, and you'll make a lot of really close friends at college. And there's a lot of different student groups if you want to get involved, and they do cool things like build rovers. I think they went to Poland a couple of years ago and competed with this rover that they built. There's another student group that's building a satellite. It's going to be launched into space.
Wow.
There's some more student groups that they're building a race car. There's student groups that are helping poverty and sustainability in Africa. There's social student groups if you just want to hang out, make friends. There's just something for everyone in the College of Engineering. So it really just leads to, it's just a family. It's a really
Right on.
tight-knit community.
It's really interesting to hear that from you and from Melanie as well about that teamwork approach and not just being on your own, but really learning how to collaborate and being creative together. That's really great to hear. I think the next one we definitely want to know about is just what kind of connections do students get to their career paths when they're in the program at the College of Engineering? And this might even lead into some stories about some alumni, I'm not sure, but just wondering about how that career path may proceed.
Yeah, I think the best way is by doing the co-op internship program. So you can take a summer, you can take a term, you can take 16 months, add on to your degree, and you can go on a work placement. And that's a paid work opportunity. And on average, our students make $50,000 a year. And that's an average. So
Nice.
really great wage, good way to earn a little bit of cash and pay off some student debt. And then as well, it gives you some good experience, because I think that's one thing that I've noticed that employers are looking for. A degree is good, but having that experience is really what sets you apart. And so many of our co-op students afterwards, I know most of the people know that have gone co-op, all of them actually have gotten full-time job after their co-op placements. So it's a really great way. I think probably the coolest co-op story, there was one student not actually that long ago that got a co-op in Tesla down in the States, down the hallway from Elon Musk, then got hired there, moved to the States, to California, worked for Tesla for a while, and then got snapped up Google. So you don't have to, work little places, or your co-op take you around the world. You get some really cool experience with that. And then I guess talking about some more alumni, we had one student who, with her mechanical engineering degree, went to work for Adidas and used her mechanical engineering degree to design shoes. We have another one, if you know the big, beautiful buildings in Saskatoon, like River Landing, we had a young alum was overseeing that project. Some of our researchers, one is developing a smart pill for cancer detection with electrical engineering. So it's really whatever you're passionate in. There's a way that you can use engineering to problem solve the different things that you're interested in, which I think is really cool.
Cool. That's so great to hear. And I mean, just hearing you talk, there's so, again, we're going back to that theme. There's so much diversity within the different fields of engineering, right? That there's a little something for everybody, especially people who like to solve problems, right?
Yeah, and I think that's if again back to the what Melanie was talking about with the qualities is a lot of times students just think math and science, but really what makes a good engineer is that curiosity and the problem solving, being adventurous and an explorer, and just like wanting to make a difference, because that's the cool thing you can do with engineering is you can impact a lot of different people.
Fantastic. Kaitlyn, I want to thank you very much for joining us tonight. I know that there are probably some people who have lots of questions. People who are watching this video after our event will probably have some questions as well. Could you just tell them again where they could find some more information?
Yeah, you can find more information online. So if you just go USask College of Engineering on our admissions page, and then if you want to email me, you can email us at engineer.recruit@usas.ca.
Engineer.recruit@usas.ca. Perfect. That's great.
Yes.
Again, Kaitlyn, thanks so much for your time. We really love that video. We love all the information you had to share with the students and everyone else who's participating tonight as well. So thank you very much.
All right, thank you.
All right. So folks, we're really grateful for Kaitlyn for showing up and showing us all of this information about the very unique first year approach at USask with this re-engineer program. That's really fantastic to hear. So folks, we are going to move on to the last segment that we have for this evening. As I told you at the start, we have four professionals from Hatch, which is an engineering company that is actually a global company that has an office in Saskatoon. And we're very grateful that these folks were able to share some of their experiences with you. So just to tell you a little bit about them, Hatch was founded back in 1955, and it's provided engineering, design, process technologies, and project and construction management to every one of the world's top 20 mining and metals companies. They have 10,000 employees in 65 offices on 6 continents and more than $35 billion US in capital projects under management. So lots of stuff going on with Hatch. As I mentioned, they have a local office here in Saskatoon, which is part of the engineering services industry. 60 employees here in Saskatoon, where they supply design and operations expertise in 3 market sectors: metals, mining, and energy and infrastructure. So again, we have 4 engineers from the Saskatoon office who volunteered to speak with you today, and each of them is from a different discipline. The first 2 that you are going to hear from are Justin Lewis and Brittany Chubey. They are going to give you insight into their careers as mechanical and structural engineers. So you think about all the stuff that you just heard from Kaitlyn and all the unique things. Now we're going to hear from some mechanical and structural engineers. So I'll be back to introduce the other 2 presenters after we hear from Justin and Brittany.
Hi, everyone. My name is Justin Lewis, and I am a senior piping engineer within the mechanical group at Hatch in the Saskatoon office. Today, it's my pleasure to present to you a short presentation, which I hope will be able to offer some insight and help you in your career path and your future path in education as well. Before I get started, I just want to say that I distinctly remember graduating high school and thinking to myself, okay, now what do I do? It's very daunting having to make a decision that big when you're 18 years old and having to decide, well, do I want to go to college? Do I want to go to university? What do I want to do with the rest of my life? Do I want to work in a trade, sit behind a desk, or do I just want to take off some time and travel? Meanwhile, you're hoping that I'd better make the right decision here. Otherwise, what happens if I end up working in a career that I hate for the rest of my life? I don't want to be stuck. I want to say that attending a presentation like this, I think, is fantastic, and I wish that it was something that I would have given more thought when I was your age. I hope that this short presentation is going to help navigate you and your future career path. Just a quick little bit about me here. I was born in Calgary, Alberta, and I graduated from high school in 2002, again in Calgary. Engineering wasn't my first choice right out of the gate. I took a little bit of time and I received a business admin diploma from SIEC in 2005 is when I graduated. That got me my first job working as a financial administrator at IBM in Calgary. I worked there for about 2 years. So in about 2007, I had friends who were graduating from the U of C with engineering degrees. They were doing really cool things. They were managing projects that were multi-million dollars. They were seeing things get built. They were being challenged, which is something that I didn't have. In my role in my job, I wasn't happy with it. It was a bit of a dead end career, and I didn't see much potential for growth. So I decided to bite the bullet, and I wanted to enroll in engineering. So I moved to Saskatoon and enrolled at the U of S as a mechanical engineering student. Once in mechanical engineering, I saw myself in a number of different summer positions with Case New Holland and Comco Controls, and I graduated after 4 years in 2011. I got my first job right out of the gate at Hatch in Saskatoon, and yada, 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 9 years later, and now the piping lead for the Hatch Saskatoon office, as well as the piping engineer process lead for BHP Jansen project. Typical day at the office. One of the beautiful things here about mechanical engineering is even throughout university, you really have the opportunity to pick and choose things that might pique your interest, which is going to help you in navigating what your career might be. A mechanical engineer might gravitate more towards machine design, thermal systems design, piping systems, pressure vessels, aerospace, electrical vehicle design, mining, computer simulations, which is something that's becoming a lot more prevalent in the industry right now. Or you may find yourself in a more broad role, such as management or project engineering. For me, although most days do involve working from the office, or these days working from home, I collaborate with a lot of other different engineers within other disciplines, such as mechanical, piping, electrical, structural, civil, what have you, to solve challenging problems. I've managed projects which involves directing other people how to solve problems, all while controlling budgets and maintaining quality at the end of the day. While most of my time is spent in front of a computer, a significant amount of my career has been spent at several operating plants in a few different provinces in the country. I've taken helicopter rides at a hydroelectric plant on the border of Alaska. I've designed piping systems at several potash mines in the province, and I've performed as a field engineer at several sites as well, including the Cameco McArthur River uranium mine. The mechanical engineering program is challenging, technically and in other ways. But that doesn't mean as an engineer that you're going to be stuck behind a desk doing calculations for your entire career. Far from it. Engineers are not, and not just mechanical engineers. We are project managers, we're entrepreneurs, problem solvers, technical sales, we may work in technical sales, we're maintenance and operations managers, we're planners, and much, much more. My career in mechanical engineering has so far been very rewarding. At the same time, it's been very challenging. But it's this challenge that keeps the job interesting and prevents it from getting stale. I've had the luxury of seeing my personal designs constructed in the field, commissioned, and successfully in operation, which is very rewarding. I've also made great connections across the country with other engineers and clients. Really briefly, I just wanted to kind of showcase different places where my career has taken me. So I've been a field engineer and project manager at several of the potash mines within the province. As I mentioned, Cameco McArthur uranium mine up in the north end of Saskatchewan. I've been to the corporate office in Toronto, spent quite a bit of time there. Calgary corporate office, as well as different client sites. The Chemas gold and copper mine up in northern BC, and that was a beautiful site. And the Alta gas hydroelectric plant on the border of Alaska and BC. I'll note that this is really nothing compared to other folks in the Saskatoon office or other colleagues that I know that graduated from engineering. They can boast of traveling to other places such as Australia, Russia, China, South Africa, South America, and many more. Unfortunately, that's really all the time I have for this short presentation. I hope it was useful in either helping you choose that maybe engineering is a path you want to pursue or maybe not. I'll leave a few links on this presentation. First one is just the U of S engineering website. I need to plug the company that I work for, Hatch. It's a great company. That's the second link there. They post job openings quite regularly. And thirdly, if you're interested in what type of financial compensation an engineer may make, depending on what experience they have, just Google APEG's salary survey. They post this information publicly after they survey a wide number of engineers in the province. So again, that's all I had. Again, my name is Justin Lewis, and it's been my pleasure talking to you today. Thank you.
Hi, I'm Brittany Chubey, and I'm a structural engineer at Hatch with just over 10 years of experience. I want to talk to you about the work that I primarily do, which is in the industrial sector, where the clients I typically work with are in the potash industry, which is where I've spent majority of my career. I want to start off by talking about my role at Hatch and what my typical work week looks like. To start off, it's very rare that my clients approach Hatch for structural needs. They typically invest in upgrading their process equipment, which in turn produces a profit, unlike their structural assets. That's where I come in, to provide support for new pieces of equipment and work closely with those disciplines, which generally are working in an existing facility, but sometimes they can be new facilities that the client has approached us to create. The other disciplines, like mechanical and electrical, provide me with the information I need, the loads of the new equipment, how does it need to be constrained, and does it vibrate? I design structural steel or reinforced concrete to support those needs If it's a vibrating piece of equipment, I ensure that it's not going to go anywhere and that the building's not going to feel its vibrations, to ensure that a person walking around feels comfortable and that adjacent equipment isn't interrupted by its vibrations. To assist mechanical, electrical, and structural to work closely together so that everybody putting in their solutions doesn't clash with one another, we work in a 3D modeling environment where mechanical models their equipment, structural models the steel and concrete, and electrical puts in their cable trays, and we ensure that we're not going to clash with one another when we go to create our drawings. It's all taken out of this one working model that we review weekly as a team. And before each discipline can properly come up with a solution that's going to work in the field, we typically take a site visit to inspect our surroundings and come up with a preliminary plan. And sometimes we get a 3D laser scan of the building, which further helps us determine where those existing cable trays, piping, or steel have been put into the facility over the years, because a lot of these buildings were built in the late 60s, and we don't have drawings that shows us all the changes that the building has seen over its lifetime. And so a scan will help us with that. There's an image of a 3D model scan. So now that we have a concept and a preliminary laid out plan in the 3D model, I use a structural analysis program that assists me in designing my structural steel or my reinforced concrete to create a model that is accurate to assess the structural integrity of a building, and that I put all my input into, and I have to ensure that is correct. That doesn't just mean that the mechanical and electrical loads that they give me from the other disciplines. I need to gather all the loads in the building, which is the dead load on the floor. So if it's a building that has multiple concrete slab floors, I need to estimate those weights and apply them to the structure. All existing equipment that is currently on the floor, in addition to the new equipment that I'm designing for, I have to apply the wind loads that are blowing on the building, the snow loads that accumulate on the roofs, and the size of design. Even though we're in Saskatchewan, we still have to consider and design for it. So once I put it all into the model, I can assess the floor locally for the new equipment load and design the steel accordingly, and look at the existing columns that are taking this new load down to the existing foundations, and ensure that the building as a whole can take the new loads that we're putting into it. The end design solution that I come up with is then provided to the client on drawings, and every drawing is stamped with my engineering seal of approval for construction, and my stamp indicates that thorough checking has been done to ensure the quality of engineering has been met. There's an image of a structural steel drawing. So now to share with you a little bit about my career path with Hatch and how I got to where I am. Hatch has been an extraordinary company for me to work for to date, and I've had a very fulfilling and challenging career. At Hatch, you're in charge of your career, and I once heard our CEO state that everyone should strive to be an expert in their field. And for me, that was steel design, foundation design, vibration analysis for finite element analysis. And early on in my career, I had the opportunity to invest a lot of my time in pushing for those site experiences, to stay late and put in long hours to become more knowledgeable and better at my job, because I didn't have the family commitments that I do now later in my career. I often share with new hires to put in that time, stay late, get noticed, and excel at their careers as it goes a long way with your employer. Don't get comfortable. Continue to challenge yourself. It was some of the best advice I could have received early on in my career before I had our 3 children. What I love about being an engineer is that I'm constantly working in a challenging environment. Even though I'm working in the potash industry, I'm working with a lot of the similar types of equipment over and over again. The scenarios and the problems that I have to deal with for each piece of equipment is generally never the same. It's always a different brownfield environment, or it's a new facility, and there's always different criteria or constraints that I must work with. And after coming from a farming background, I still enjoy my site visits and that opportunity to get out of the office. Thank you for having me. I enjoyed sharing with you my career to date, and I hope that I've inspired all of you to take on engineering. Here's just an image of the last project that I recently worked on, and it was installing pre-assembled modules into the top of a building like Lego pieces. Thank you.
Awesome. We want to thank Justin and Brittany so much for sharing that experience. So we looked at the mechanical and the structural side there, and students, I just think about, you think about how much you would learn between now at this point in your life and by the time you enter the workforce in order to be an expert in your field, just like Brittany was talking about. I think that's so exciting, and so we hope you guys are going to follow that path. So 2 more presentations from Hatch. We're very thankful that Graeme Whitecross and Craig Lytle are going to share their experiences with you very briefly here. By the way, it's amazing that these folks could compress all of their experience into these short 5 or 6 minute presentations. So we're very thankful for that as well. Graeme works in controls, automation, and electrical engineering, which is very, very interesting. And Craig is an electrical engineer. So we're going to hear about their experiences. So I'm going to turn it over to Graeme and to Craig.
Hi, everyone. Thanks for joining. As you can see from the slide here, my name's Graeme Whitecross. I work for a company called Hatch. It's a global company, but we have an office right here in Saskatoon, and that's where I live and work. So what do I do? A little bit about myself. So my official job title is CA&D engineer. So that's a bit of a wordful, but it stands for controls, automation, and electrical. So what do I really do? So I work with control systems and automation, often for industrial sites, like, for example, mines, a lot of the potash mines around Saskatoon. So what I do is I design and I work on the systems required to make sure that these mines and these plants run. For example, like these plants need sensors, like to measure temperature or pressure. So we need to select these sensors, install them, and wire them. So we need to do that. We need to have a communications network. So it's, for example, your cables and your fiber optic networks, so that all the parts of the plant can talk to each other. I also work with the control systems. So we program control systems to, for example, turn motors on and off, or to open valves, just to do the things that need to get done in order to make a product. And so, but doing those things, I get a lot of variety in my work, which is great. So we do many of the projects we design, we start in the office and we do drawings and design and sketch things out, and then we create drawings. But for a lot of our projects, we then get to go to site and actually get to go to site, make sure it gets built correctly, and then help test and commission it. So we actually get to see our designs kind of come to life, which is a really cool thing. Commissioning is something that I personally really enjoyed. So that's testing, troubleshooting, making sure that things that we make work and work correctly. It's a hands-on activity where you get to see things come to life, and we troubleshoot to make things work. So I get to do a lot of different things in my job, which is fun. As I said before, I'm Saskatoon raised. I've lived here for almost my entire life. Engineering was something that was not on my radar until after high school. I actually didn't know anything about engineering until I got to university. I did a couple other things at university before I joined engineering, kind of on a whim, to be honest. But I did join the College of Engineering, and I graduated at the U of S in 2011 in electrical engineering. Since then, I worked with Hatch in the controls and automation department since then. It's been a good journey. I remember my first 2 months I spent working on sketching some wiring diagrams, kind of trying to figure out what I was doing. Didn't really feel like I knew it. Next thing I knew, I was on site helping on an expansion project at the Mosaic Colonze mine, which is east of Saskatoon. Originally, it was supposed to be 2 weeks, and that turned into 2 years. But it turned out to be an awesome thing. I got to work on, this is a picture here of a control system screen. So this is how someone sits here and actually turns motors on and off. They get to monitor things like pressure, temperature, things like that. So I got to work on this stuff all day, which I'm kind of a geeky guy. So I thought it was a great way to start my career, and I learned a lot. I also got to do stuff in the field. So this is a control cabinet showing some of the control systems components. There's wires and controllers and fiber optics in here. It looks daunting, but you start to learn it quickly, and it's really fun. Since then, I've worked on tons of projects, mainly in potash, but all over from surface. And I've also had the fortunate time to go underground, which is a whole other world. So you can see in this picture here, it's really neat to go underground if you ever get an opportunity. It's a really neat thing to do. A typical day for me is it's hard to pinpoint. It totally depends on the project. A big part of my work is communication and working with others to understand how to make a design work, how to get those sensors together, how to put that network together. I'll sketch and draw designs and then work with others to help create a formal drawing. I'll check and review the designs of others. So that's kind of on an office basis. And then when I am on site, I'm often in the field working with wires and electricians and other people to test and make sure that components and systems are working correctly. So that's what I love. One of the things I love about being an engineer and what I do is I have such a variety in what I do. I work on different sites, and working on site is so different from working in the office, and different industries too. I've had the chance to work in some other industries like copper and uranium as well. Another thing that's great about it is it's constant learning. You're not going to be bored, let's put it that way. There's so many new things to learn, and I still feel like I know so little and have so much more to learn. And the other things are just, I kind of get a personal satisfaction in helping create something, especially something that I personally designed, getting to go out to the field and seeing it built and then tested and operated. It's a really cool thing to see something go from a piece of paper that you thought of and then actually working out on a site. It's a really, really cool feeling. And that's all I have. And thank you for listening today.
Hi everyone, my name is Craig Lytle and I'm an electrical engineer working with Hatch. So I'm going to do a brief presentation talking about what my role is with Hatch, how I got on the career path to get to this role, what my typical day looks like, and what I love about being an engineer. So my role at Hatch is I'm an electrical engineer doing the design, installation, and commissioning of power systems, mainly in Saskatchewan for our mining clients. So how did I get to this career? Well, I started off in high school. I really liked electronics, programming, computers, and I thought engineering would be a good, interesting way to do all these things without being forced to be stuck at a job or a desk job, because I always like to get out and do stuff and get my hands dirty doing things. So I went to engineering at the University of Saskatchewan, and I found electrical engineering really piqued my interest because they had lots of interesting labs and classes that I thought were a lot of fun. Two of the most interesting ones that I had were some design classes where some of the highlights were I made a DJ glove to replace the turntable system to control the DJ setup just by gestures and button presses on the one hand, so you could wear it at a party and change music while just having this glove on. And then another one I made a neat thing that would let you start your car from your cell phone back before most people even had smartphones. So with these interests, I started applying for jobs after university, and I found Hatch as a consulting company offered the most variety and interesting career opportunities for me. It also let me travel around and explore the world if I wanted to, or even just stay in Saskatoon and work on the stuff around here. So with Hatch, I started out by going to one of the mining sites just a few days after I started my career. I spent over a year there working on the mine power system, generators, substation, and other major electrical equipment. And it really let me see a good hands-on of what we're doing in the electrical industry and how it applies directly to the mines around the province. After that, I spent a bit of time in our Saskatoon office before I spent a year flying up north to one of the northern mines where I'd work for a week there and then it'd be a week off back home, doing some major electrical installations and upgrades up there. And that was a really fascinating experience because I was away from home for a week at a time. I was working underground a lot and got to see really, really neat things and lots of different wildlife and all sorts of different challenges and experiences that I never thought I'd get to do if I was just stuck at a desk job. And now my career has kind of taken a bit of a different turn. I'm still working on a lot of the mining projects, but we're also trying to strive out and get into some more technology development stuff. So we're looking at some underground automation for automated vehicles, similar to what you'll see companies doing around the world for like self-driving on cars on surface, but it's starting to happen underground as well. And Hatch is looking to be a leader in that. So it's kind of a different industry almost, and very different from my normal job. And it's really interesting to see the new technology and being a part of its development. So what does my typical day look like? Well, since COVID, it's been mostly sitting at home in my desk here, as you can see. But before COVID, it was a lot of variation between doing a design at my desk and then following that design out to the field to see it installed and tested, commissioned, and then turned over to our client, which is a cycle I really liked because you got to see your mistakes, got to learn from those mistakes, and you got to apply it for the next job that I was working on. So typically I'd spend in the average year probably a few weeks to a few months at a mine site working on the site stuff, and then the rest of the time would be in the office with maybe a day or two a month going out to these sites to gather information. And so what do I love about being an engineer? I love that it's always different. I don't want to be stuck at a job where I have to do the same thing day in, day out. I want to have new and exciting problems to work on. I want to have the opportunity to travel if I want to. And that's something that being an engineer lets you do. There's infinite possibilities for, especially electrical engineering. Everything now has electricity in it. So you have the opportunity to pick and choose what you want to do and take it wherever you want to take it. Electricity is the same here as it is in Australia, as it is in Europe. With obviously a few differences, but there's been lots of opportunities through my career where I could have traveled if I wanted to all these different sites. So yeah, being an engineer has been great. It's kept me thinking of new things, learning new things. I've never felt like I've stagnated or had to just do the same thing day in and day out for months or years at a time. It's always new challenges, new things to learn, and new things to see as I follow my work around and see it get installed. That's it for my presentation. Thank you.
Hey folks, we really want to thank once again Craig and Graeme and Brittany and Justin for sharing their experience, and for Hatch up here in Saskatoon for arranging these folks to share their experiences with our students and parents and teachers who are with us tonight. Folks, very importantly, as we wrap up here, at the Saskatoon Industry-Education Council, we really rely on feedback for many reasons. And you can see on your screen right now, whether you're with us live or you're watching this afterwards, that we have a QR code or a website there. If you could take a moment, please, right now, just to follow where those links will take you, and just take a minute to fill in a quick survey. We would really appreciate some feedback on our event tonight so we can continually improve our programming. And also, I just want to tell you about a few upcoming opportunities that we have as well. Right now, we are in our manufacturing and mining events. I mentioned before that there are several post-secondary opportunities in our province, as many of you would know. Saskatchewan Polytechnic, we have a separate post-secondary series focusing on some of their programs, and you can check that out on our website. And we're also hosting a scavenger hunt at a local manufacturing facility, which is going to be really interesting to see the inner workings of that facility. That's happening this Friday, November 27th. All of this and many, many more resources are available on the link that you can see there at our saskatooniec.ca website. Also, coming up, we have a few more months that we are going to be going through and focusing on a different industry every month. You guys can see that on your screen right now. All the way until May, and you can see several themes in there that relate to engineering as well, and these different themes that we have, different industries will be focusing on. So make sure you follow us on that website, and you can also follow us on our social media. We have a few different places where you can keep up to date with us if you're on any of these social media platforms. And again, checking out our website or our blog, we have guest bloggers who share information. Again, I want to thank Michelle Hardy for helping out behind the scenes today, and thank all of our presenters, and thank you for your time and being a part of this event, this engineering career panel. Thanks very much, and we hope everyone stays safe.